my students, this lesson comes from chapter 9, section 1 in our textbook, and it's titled Quadratic Graphs and Their Properties. So the standard form of a quadratic function is y equals ax squared plus bx plus c. Now the only requirement of this is that a cannot be equal to 0. So that means there has to be an x squared term in this. The bx doesn't have to be there and the c doesn't have to be there. One of them can be there, they can both be there, or neither of them can be there. But the x squared has to be there. So let me just write down some examples of what you might see for a quadratic function. So you could see y equals x squared. So the a value is 1, it's not 0, and the b is 0 and the c is 0 in that case. You could see it written in function notation. So you could have f of x equals, a could be a fraction, so 1/2 x squared plus 2. So that's a quadratic function. The a value could be negative. So how about y equals negative 2x squared plus 3x minus 1. So in that case, we have a b value and a c value. And the b and the c can be positive or negative. So all of these are examples of quadratic functions. Again, the key thing is it has to have an x squared in it. If it doesn't have an x squared, it's not a quadratic function. So let's look at a graph of a simple quadratic function. So this is as simple as we can get, right? Y equals x squared. The value of a is 1. There is no bx or c. This form is known as the quadratic parent function. So the simplest form we can have of a quadratic is called the quadratic parent function. So x values, to graph this, we're going to make a table. My x values, I can pick anything I want. So I pick negative 2, negative 1, 0, 1, 2. I plug those into the quadratic function, and I'm just going to square the x value. Remember, a negative squared, negative times a negative is a positive. So that's why this is positive 4. Square that, you get 1, and so on. And that gives me ordered pairs. So the x values and the y values give me an ordered pair that I can graph. Remember that the x values, we're going to talk about this more later, the x values, your input values, are also known as the domain, and the output that you get, the y value, is known as the range. So we'll come back to that later. So when I graph that, this is what I get. And so you can see it's kind of U-shaped. Move these out of the way. So down here in this red box, it says the graph of a quadratic function is a U-shaped curve, and this U-shaped curve is called a parabola. The graph is symmetrical about the axis of symmetry. The axis of symmetry I put in here is this red dashed line. And to say that this is symmetrical, what that means is the left side of the curve, if I was to fold it over, it would match up exactly with the right side of the curve. So you can see when you plugged in negative 2, you got positive 4 out. When you plugged in positive 2, you got positive 4 out. So the left side and the right side are identical, and that's called symmetry. The line that splits them in half, that's known as the axis of symmetry. And the last piece of information on this screen is the vertex. So the vertex is this point right here. It's at the bottom of the U, bottom of the parabola. That's called the vertex. We're going to talk more about the vertex in just a few minutes. All right, so let's move along. So here's our quadratic function in standard form. F of x equals ax squared plus bx plus c. Again, the only requirement is that a cannot be equal to 0. So you don't need the bx or the c, but you have to have the x squared there. So this is really important. If the a value is greater than 0, meaning if the a value is positive, then the parabola opens upward. Let's see if I can slide this down here so you can see this. If the a value is less than 0, meaning it's negative, then the parabola opens downward. So on the left, you have a graph of y equals positive x squared. So coefficient of x squared is 1, so the a value is positive 1. Over here you have negative x squared, that means the a value is negative 1. So the positive a value makes it face upward. The negative a value makes it face downward. Okay, so if we change the sign of the a value, it flips the parabola. Positive facing up, negative facing down. So next, I want to look at the width of parabolas. So how wide they are, how fat or wide the u is. So this first graph is the graph of f of x equals negative 4x squared. Notice the parabola is facing downward because the coefficient of x squared is a negative number. Next is f of x equals 1/4 x squared, or 0.25 x squared. It's positive, so it's facing upward. And then the third one here, I just have f of x equals x squared. So the coefficient is 1 here. And again, it's facing upward because the coefficient of x squared is positive. So what you should notice is that as the coefficient of x squared increases, and really I should have said as the absolute value of the coefficient of x squared increases. So we're not concerned with whether a is positive or negative. We're just concerned with its absolute value. So the absolute value of negative 4 is 4. So what you're comparing is 4, 1/4, and 1. So the largest absolute value would be this 4 here. And that's the narrowest one. The smallest absolute value would be the 1/4, and that's the widest one. So as the absolute value of the coefficient of x squared increases, the width of the parabola decreases. So the bigger the a value, the bigger the absolute value of the a, the narrower it is. Okay? So next thing we're going to do is look at what does c do? What does this value of c do? In this lesson, we're not going to look at what b does. We'll be looking at it in another lesson. Today, we're just going to look at what the a does and what the c does. So we've learned that the a, if it's positive, it faces upward. If it's negative, it faces downward. And we've also learned that it affects the width. So the larger this value of a is, the larger its absolute value, the narrower it is. So here's a quadratic function without a c value. So the c value is 0. This one has a c value of +2. This one has a c value of -3. Sorry, these keep getting in the way. So let's look at the vertex. So the vertex is right here. The vertex, the coordinates of that, I know it's really small and hard to see, but the coordinates of that are 0, 2. The vertex on this one, the coordinates are 0, -3. So hopefully you can see what this c value does is it shifts the parabola up or down. So it's a vertical translation. So it's moving your parabola either up or down. Specifically, it's moving the vertex. So when the c value is 0, the vertex is at 0. When the c value was 2, the vertex was at 0, 2. When the c value was -3, it was at 0, -3. Okay, so the value of c translates the graph either up or down. A determines whether it faces up or down, whether it opens up or opens down. Positive, it opens up. Negative, it opens down. And the absolute value of A determines the width of the parabola. All right, so I said we were going to come back to finding the domain and range. We're going to talk about that some more. So here's an example of a quadratic function, and they're asking us to graph it. And they're also asking us what is the domain and the range. So for my input values, I can pick any number I want. Right? There's no limitations on this. You could plug in positives, negatives, decimals, fractions, whatever you want for x. I chose 3 and 6 and 0 because 3 and 6 are multiples of 3, and I know that's going to end up canceling out this fraction and leave me with whole numbers. So it'll make it easier for me to graph. So when I plug in 0, 1/3 times 0 plus 1 is 1, so y equals 1. When I plug in 3, 3 squared is 9. 9 times 1/3, that's the same thing as 9 divided by 3. So that's 3 plus 1 is 4. And when I plug in 6, I get 36 divided by 3, which is 12. So my ordered pairs I have are 0, 1. 3, 4, and 6, 12. I'm going to graph these and try my best to draw a parabola. I will warn you right now, I'm terrible at drawing parabolas, so this might look really bad. Hopefully you're better at drawing them than me. So my first point is at 0, 1. This is, the steps here are by 3. So I'm just going to kind of guesstimate this. So 1.5 would be in the middle, right? So 1 is somewhere about right there. And then I have the point 3, 4. So I go right 3 and up 4, which again would be about right there. And then 6 and 12. So hopefully you notice this does not look like a U, right? Well, I know that this is a quadratic function, and I know that quadratic functions have symmetry. So I know that the left side of this looks exactly like the right side. So I can just mirror these points over here. So I know at -3, it's going to also be equal to 4. And at -6, it's going to also be equal to 12. Now I could have put those values in here. I could have put -3 and -6 and gotten those points. But since I know that this is symmetrical, I saved myself some time by just doing the positive side and then mirroring it over the axis of symmetry. All right, so this is my chance to draw a parabola. This is not going to be pretty. Let's see. Most of the time when I draw it, it ends up looking like a V, which it's not supposed to. It's actually not terrible so far. Well, I shouldn't say that. Well, it's not pretty, but you get the idea. So keep in mind this +1 here, our C value of +1 shifted our parabola up 1. Right? So it was a vertical translation up 1. So back to the question of domain and range. So the domain in a quadratic function, your input values, is there any limitation on what you can plug in for x? Can x be any number? And the answer is yes. So the domain in a quadratic is always all real numbers. And if you want to use the symbol, this R, you can do that. So all real numbers. For the range, the output, so if we look at our graph, so the graph is a picture of your outputs, right? All of our outputs are up above +1. So they're all up here. There's no values down here. There's no lines down here. The output does not go below 1. So what we say for the range, the y values, all of the y values are going to be greater than or equal to 1. So you cannot, it doesn't matter what x value you plug into this, you will never get a y value out that will be less than 1. It's always going to be greater than or equal to 1. All right, so I'm going to show you a couple more examples of that. I've got some graphs here, and so we're just going to go through and write down what the domain and range is, and we're going to do that just by looking at the graph. Get this out of the way. Okay, so the domain, again, is all real numbers, and that's true for all of these. There's no limit on what I can plug in. So all real numbers. So the domain piece is pretty easy. All real numbers. And now let's go back and look at our outputs. So if you look at your outputs here, all of the outputs are from a y value of 2 or greater. There's no outputs down here. So for our range, we would say y is greater than or equal to 2. The vertex of this one is at 0, 2. Okay, the vertex at this one, let's see, 1, 2, 3, 4, 5. Yeah, this is counting by ones. So the vertex of this one is at 0, -3. all of my y values are above that. So there's no y values that are smaller than 3. So we would say y is greater than or equal to 3. Well, what if we have a downward opening parabola? So if you look at this function, the a value is negative 0.5, so it's opening downwards. So in this case, all of our y values are down here. All of the y values are below 1. So in this case, in a downward facing one, you would say the y values are all less than or equal to 1. Okay. So I hope this helps you out. If you enjoyed this video, please like and share. Until next time.